Hey everyone, sorry for the delay. I got a new a new setup here.
Hello, Dan.
Hey Elon, good to hear from
Uh,
you.
yeah, it's your third day.
Yep, yeah, yeah. It's going okay, but yeah, it's a lot to learn. So it's nice to have some familiar things to do right now.
Yeah.
Let me share this. Okay, and yeah, I spent a lot of time, or I've been transitioning or took time off, and so some things haven't moved as far as I wanted to, but I wanted to go over the hot topics. Um, any other things people wanted to talk about that maybe is not on this list, or in general? And if something comes to mind, just let me know. Otherwise, we can just kind of start walking through it. So one of the first things then that I wanted to circle back on with Sean is hiding the KVM pointer. So currently, the only place we have it currently is in the bind API, TSM bind, and Sean wants to move that to struct KVM file, and Anish has a proposal out there. Have people seen that that thread
Yes. I see that thread.
over here?
Hmm?
Um, yeah, but uh, any other feedback about that, or I guess we just need to move that into the staging tree and do an implementation of it. So Bashan had the question: how much out of the struct KVM pointer do the implementations need? And ARM only needs the realm pointer. Intel only needs the TDR page. Is that right, Yulun?
No, I have replied in that thread that for for this bind callback, we only need the TDR page. But there are some other connections between KVM and LMMU driver, and that needs some details about the SEPT, like the SEPT page table levels. Now it should be 5 level page table. So this information need to need to inform the RMMU, and also the AD bit enabling. Is the AD bit enabled on SEPT side? So the RMMU side should think upon that. Uh, yeah. And another thing is that the RMMU driver may need a notifier from the KVM to know when KVM want to update want to flash the SEPT TLB. So and at the same time, ILMMU should flash its ILTLB.
But we think it's like a literal notifier, or is a KVM callback,
Mm,
or no? Okay,
it's the KVM callback for this notifier.
but we don't. But that's hmm. that's not TDX specific. I mean, that's not TDX specific.
I think maybe that is TDS specific. I know that ARM has maybe ARM also has a need to have this callback because they also share the second level page tables and the L page tables. But I think to sync these TLBs, we need some specific firmware interface alignment on that. So I can see that the firmware alignment requirement between ARM and Intel may be different.
You mean the alignment, the page alignment, or the
like the sequence, like the sequence order of the SIM call.
Okay, yeah, I will take a look and see what ARM has there. They might already be out there in Anish's patches.
Yes, like for Intel, we need to the TDX module want to ensure that the SCPT flashing and the LTLB flashing are done atomically. So it invented multiple SIM calls. Like first the host need to issue a track start, and then use other SIM calls to do SCPT flash and use SIM calls to do LTLB flash, and at last it advances the track epoch. This is a specific protocol that TDX need to ensure the flash is done. And I can imagine that ARM must have different requirement on that.
Okay, yeah, that makes.
Is there a button to raise a hand? Hey, I was a bit late. So one of the comments I got when I posted IOMMUFD with GMMFD patch was that GMMFD needs to notify IOMMUFD if some of the memory IOMMUFD received from MMFD is going away. So that there is going to be a notification mechanism like this, for this kind of events, at least. And it's like not platform specific at all.
Is that accurately working on that? Do you know? Do you have a lower link of who's working on that?
I have very rough prototype, but I didn't post as a patch, so I don't know if anyone else is working on it. Anish might, because Anish is pushing patches around this area.
Okay. So, but this notifies something you have in your tree.
Say it again.
You have this notifier implemented in your tree, or this is something you want to do?
I do have some rough sketch. It's just I don't need it right now because I don't play with memory hot plug and the guest. But when I start, then I will need something like this.
Oh, I see. Okay, so maybe something that could help us in the meantime on the for KVM. Okay. Okay. But then Alexei, the stuff you need from struct KVM. Did you see that thread with Sean? he's asking like,
I really don't see what's the problem here. We can extract KVM pointer from KVM file. Just we need some starting pointer, and then we can unroll whatever we need when we get the TSM platform driver, right?
I think, I mean, that's also my position, but he seems to think that, well, the question was, do you only need this one little bit of information, or do you need a whole bunch of stuff? And
we want TSM driver to decide what it needs.
So I think we just grab the KVM pointer from the file and grab everything and just go with it until.
Then we cast it to SVM CPU, and so the thing I need is just context page to identify the guest when you talk to the PSP.
Yep.
So it's a single pointer and maybe ACID, like two things. But it's in KVM, CPU, whatever SVM struct. So I can get to that thing if I have KVM file descriptor or KVM pointer or whatever. So I would do it, but from is happy with.
Okay, so maybe we'll just go ahead and change the bind ABI to take KVM file and just go from there.
Yep.
Okay.
Yeah.
Okay, so just
unrelated question: is there much of background noise when I speak?
There what?
Is there any background noise when I speak?
Yeah, I can hear background noise when you speak.
You do hear or you don't?
I do hear.
Sorry about that.
Okay. Yeah, so I mean, I think we just do that, and then he can see the implementations. Like there's not much more that the infrastructure can do. I did get a reply from James about the BridIO pipe thing, and he also asked the same VSOC question. That we still want, or I think we still want, or what I think we don't want is all these kind of buggy re-implementations of just passing blobs of data around. I haven't seen any updates on this if other people are joining in the fight here, but I still haven't been disabused of the idea. So I don't know, Vivek. I remember you had expressed some interest. I don't know if there's.
Yeah, I've been looking through the code, Dan, and trying to figure out all this. I've been talking to Peter a few times as well, right? So we just had a chat a couple of times, and he wasn't like, we also got confused by that thread that you're talking about, where like people are suggesting VSOC and stuff, the thing, but. Now, we're just looking for some direction from you on whether we should continue implementing the VFIO MMIO path, or should we have some more conversation before we decide on that? Like, I think that's where we left now.
Okay.
But,
yeah. Okay. Go ahead. I cut you off. Sorry.
No. I was just saying that I'm not waiting for that. I'm just looking through the code and looking at tracing through the things. I'm kind of new to this one, so. Well, I'm ramping up on the code, but it'll be good to have some direction on, okay, so irrespective of what we are seeing in those threads and stuff like that, let's just at least prototype it, or let's just wait a little bit. I think that's kind of the guidance we are looking for. Yeah.
So maybe produce like a skeleton or an architecture
I'm a little lost here. Virtual pipe is a replacement for that netlink, or
no.
DHCP.
For yeah, so for guest requests, at least for
Right. Okay.
bulk guest requests, yeah.
Good.
Um, or so something like this, Vic, like just say,
Okay.
hey, like, take, yeah. So I mean, that might be something good to take the next thread with James. He might have a alternative proposal. So I kind of expect him to reply to what I said, and we can go from there. I mean,
Okay.
the alternative to get started, we could do it could be something gross like on the host you do netlink as normal. On the guest you can do netlink, and netlink will find out like, oh, hey, there's nothing populated yet, and then you have to do a VSOC to grab it, and then VSOC to inject it into the guest kernel, and then netlink will work. It's super messy, but it at least, I don't know. There's stuff we can do there just to get the kernel ABI going, and then we can replace it later.
Okay.
Kind of idea.
And Peter also told me that the TDVM implementation is going forward as well. So that is there as well.
TDVM. Remind me what TDVM is again?
So just going through a TDVM call for this get blob, even though we said this is not scalable, it's going to be a large blob and stuff, but the current implementation that's going forward is through a TDVM call.
Yeah. No, that makes sense. I mean, like the TDVM call gets you up to a certain size, but then like when we need to get to 16 megabytes of PCI data, it falls over again.
Yeah.
That's fine. Okay, I think that's all on that one.
Okay, so I think like just to summarize, so I'll start sketching a starting point for the MMIO implementation, right? So.
Well, I think you sketch it. I was thinking like more like you were saying you wanted some more kind of arc direction from the community, and so maybe I was thinking that was more of a resolution of the thread with James. I guess so maybe that's the first step, Dan, to resolve.
Oh, okay, yeah.
Yeah. Go from there. Okay. So the next steps on this whole device trust proposal that we talked about with Greg and Jason is that it basically it needs the transition to be to start using, like, to enable DMA, all these things, and start accessing private memory to be disconnected from the accept callback, so that the only thing accept would do is put the device into the run state so that it's ready to be trusted. So you gather evidence, you validate it, you say it's good, you tell the device, yeah, you can enter the run state, which means that you can start accessing private MMIO with the device. But when you but it's still okay. What the state that this trust thing wants is to say, like, hey, I still don't trust the device to access private memory, but I do want to take advantage of IDE and encrypted MMIO, and so that would be a level of trust that you could run with. And so it could be the case that you actually put the device in run state, operate it that way, and still never let it access actual private memory, and the driver always still uses bounce buffers and these kind of things. So that's a little bit different than the way we had it, where we had an accept state that said, oh, it's accepted, so I can do everything all at once. So it's kind of separating the mechanism from the policy. As I'm starting to think through what that means, it looks to me that whatever mechanism, like a sysfs knob to say the trust level of the device. So if we express ultimate trust in the device can access private memory. To me, that looks like something that notifies the IOMMU driver in the guest to say, hey, IOMMU driver, user space says we can trust this device to access private memory now. So please turn on all the fancy features that you can for this device, and that could include access to private memory. And so then the IOMMU layer would call back the TSM driver saying, hey, TSM driver, we're ready to allow private memory access for this device. Do whatever TSM architecture TSM calls you need to do to turn on DMA. And so that would mean that all the places right now where we have device CC accepted, or we check to see if the device is operating with private memory access enabled, that would probably be something that we would move to, I think, dev IOMMU, like that bit of data that each device has from its IOMMU that says, okay, this device is operating in private mode in the guest. So that's my rough talking through it idea that before I start writing up a patch or a change log. Did that description make sense about what needs to change here?
Sounds good to me. For a long time, we considered config blocked as a run state, like same thing. So really makes no distinction for us.
Well, that's yeah. Lock is effectively the run state, yeah, and this is effectively the same because you're basically saying, yeah, it's well, even in lock state though, you can't talk to private MMIO yet, right? I mean, from a trust perspective, yes, it's the same, but you still can't access private. So this, I guess, that'd be the only difference is in this state, you've gone from lock to run, but you can't access private memory.
I would allow private from like from the first second actually, private MMIO. If I can do private MMIO, that's the first thing I want to enable. Because it only increases protection. You don't lose anything.
You don't lose anything, right? Yeah. And yeah, so it's all positive. Like you don't need to trust the device to turn on that protection. That's right. So, but the other implication of that is that we're definitely going to invoke run before we do enable DMA. We might never do enable DMA. But that also means that if we, for some reason, lose trust in the device, and we want to go back to, oh no, this device should only go back to that state of devices running, but no access to private memory, that would mean that we can turn DMA on and we can turn DMA off. That would be, and that would be DMA off before run state. But this is where we had the question about the TDX requirement.
Yes, there's no TDX interface now to say let's turn off DMA but keep the device run.
Okay.
Yeah. But I think maybe we could raise the requirement. Previously, for the page accept, that is the accept the page for vCPU access, we have something like page accept, and later we invented the page release schema. Yeah. Maybe it is possible that someday we could invent some DMA accept and DMA release.
Because TDX depends on this for the DMA mitigation. I thought that and this is where Lexi and I were having the conversation about, because I said, yeah, we must not, we have to do disable DMA before we have to do stop device before we turn off DMA. Otherwise things go bad. But that was for the crash case where you have to disable DMA because KVM unmapped the page, or KVM crash, or KVM tearing down. But in that case, that's an error case that brings down the whole TVM.
Yeah.
So it might be the case that on Linux is going. I think is going to want to do this. Turn off DMA and trust that because if the guest asked for it, then it's not a security vulnerability. Like it's
yes. I think that's a point.
Yeah.
Because previously we need to first stop device, then blocks the DMA. It is because TDX module team are afraid of the silent DMA drop things, that the VMM silently drops the DMA without notifying guest. But if there is some interface that guest explicitly ask for DMA blocks, that would not cause the DMA drop silent drop things, because it is not silent.
It's not silent, yeah. But I mean, yeah. So really, it's not like there was never a TDX call to say disable DMA because they thought, like we always have to stop the device.
Yeah.
So raise that. I'll try to get. I think a niche. I think CCA is fine can also support that too, and it would just be something that we would have to either quirk or just say, like, oh, by the way, on some implementations, if you try to go backwards, you lose protections. You lose. You can go back. you can run the device, you can turn on DMA. If you try to go back to turning off DMA, you lose private MMIO. But all of these operations need a driver unbind flow anyway, so it's not like these are things that can just be turned on while the driver is loaded. So I don't think that's too bad. And so it would just be a symmetry, nice to have thing, not a total requirement.
Okay.
So but I would ask them. Returning from any other comments on that one?
No. I have another thing for this new accept process. I see that you have some conversation about the trust level definitions, like I can't remember fully. Like trust level 2 refers to DMA enabled, but ATS not enabled. Trust level 3 means ATS also enabled. But I see that from TDSP, as I understand that the ATS enable, the decision of ATS enabled or not should be, it should be decided on TDI bind. You need to configure the ATS beforehand, then you lock all the configurations, and then the device report would indicate if the device has ATS enabled or not. That means when you have accept the device to the run state, you cannot change ATS anymore. Then it means that if you have already accepted the device, then the kernel want to set trust level 2, it will not success. You must set to trust level 3.
Okay, so we're still protected. Well, because the DMA is still disabled.
Yes. But you cannot change your secure level as you want.
Yeah. So if we said, okay, hey, we want to turn on ATS but not allow private memory, we can't because or we want
to access private memory, but we don't want ATS.
Yeah, I don't think we'd ever do that. I think the way we would define these is that each level would be a superset of the one before it. So because the idea of an ATS level is, well, yeah, I guess I see you're saying like that. You may not want to trust the device if it's in ATS mode. You may only want to run it in IME protected always translation mode. That makes sense.
Yeah.
Okay.
Sorry, I'm missing the point here. When you enable DMA, you don't want to enable ATS right away. Why?
if
the hardware supports.
If the hardware supports it, but it's if you, well, I mean, I think for TDIS it's not as big of a problem because ATS will have to be a secure ATS. Like there's no kind of, it's not like ATS allows you to go outside of and go clobber other private memory. The idea of having ATS in this trust thing was for the bare metal case, really, so the bare metal can say, because right now the only policy we have in PCI core for ATS trust is this untrusted flag, which is basically just set if an ACPI table says that the device is internal or external. But you may want to use SPDM or some other kind of validation to say, yeah, I don't care. I don't like the untrusted flag is not enough. I actually want to get I want SPDM to tell me this is the actual device I'm talking to before I turn on ATS for it. But what Yulun is saying is that if you don't trust ATS, you can't disconnect your ATS decision from your TDIS decision. Like that's done early.
Yeah.
I need to read about ATS. How can you not trust ATS? You're the host and
how can you not trust ATS? I mean, like in the bare metal case, like if you don't trust that the device is not going to go abuse its ATS to go get things it shouldn't get.
If you enable DMA, that's the ultimate trust. If you enable DMA form, then you're screwed anyway. ATS or not.
But if you enable DMA and you still have IOMMU protection, then the device can't.
Plain DMA, just physical memory.
That's true. Yeah, like if
See my confusion, right?
I see your confusion. You're saying that like that the ATS mode is identical to the physical mode in terms of damage that the device could do. Is that what you're saying?
Pretty much, yes. Yep.
But,
I would think ATS is more restrictive than. Yeah. Speak.
Well, yeah. The concept of the trust level is to be able to express things like, I am okay to operate this device if it has IOMMU protections, and so that would include physical and ATS. So basically, like I want to talk to the device, but I only want to talk to it if it definitely has an external address validation mechanism to stop it from doing things I don't want it to do. So that might be the way we need to define it is I trust, I need IOMMU protections or I don't, and not really. So that's not really an ATS thing. Per your point, but then we have this problem of like, how do we? But the I guess that would be there would probably be a global policy. Not even global. It wouldn't be global. Like when we have ATS in the TDIS case, we have to request it, right? Or is it, or at bind time we just get whatever we have to accept whatever the TSM, like the driver with whatever the firmware chooses. Do we get to choose that? Do we get to say like, oh, hey, I want to accept this device, but I don't want ATS? But so, or it's just like, no, you get the interface report and it says ATS is on, you either accept it or not.
I think we can choose. We don't have to do it on firmware. Yes, we have to do it on phone. We need the firmware to do something. Yeah.
Because for me, if I want ATS, secure ATS, I just that SDT write message from the guest to the PSP. It says put this ATS bit 1. So, but I think I can do it like anytime I want from the guest.
No, you cannot, because you cannot do this at any time from the guest, because when you have locked the device, you cannot change the
I mean anytime after config locked. Yes.
Anytime after config locked. No, after you have locked the device, you cannot change device ATS capability anymore. Because
I was talking
the
about
TDS,
the IOMMU side of things. The IOMMU side, I can enable, disable. And then
yep. Yes, on IOMMU side, you can enable, disable. Yeah.
Okay, but not on the device. Good point.
But seems Intel VTD spec has some highly recommended suggestions that you should not make the two partners you cannot make disagreement on the two partners. That you should when you enable the device ATS, you should always enable the ATS capability on IOMMU side.
Okay. Yeah, but so that's a good point. I need to think through the trust levels, and it would probably need to be something like that you can't disconnect it, and that if you said, hey, I want to operate this device, but I don't trust it if it has ATS, then you would not be able to transition. So basically, so the idea is that every time we try to raise a trust level, it would notify the IMU driver, or anybody else that can say something about that trust level. And so, yeah, I think we would have an explicit trust level that says, hey, I trust. Well, actually, no, you would need to. I'll think about it, but like, we're gonna have a case where it says, sorry, no, you want to run the device, but to run this device, we have to turn on ATS. But then again, I don't think it matters because that will be a DMA disabled case. So it would only be that final step where you say, yeah, I want to turn on everything. Then the ATS setting doesn't matter, and I don't think we need to support a case where it's like, yes, I trust this device to have access to private memory, but I don't trust it if it has ATS. But
I think maybe we can make some simple classifications that yeah. Just if you trust the device, you cannot stop it from using secure ATS.
Right. Yeah. At ultimate trust, you trust secure ATS.
Yeah. When you trust the device, you must trust every configurations of this device. So if the device said I have already turned on the ATS, you cannot say I want to disable ATS at runtime.
But again, but then again, it wouldn't be runtime, right? Like because you saw it, like you saw the interface report, and you said I want to go to the run state, knowing that that was done based on the interface report. And so if you later say, like it wouldn't be a surprise that you get ATS because you saw it.
Yeah.
And
you
if you don't
have already agreed on the attestation time.
Right.
Yeah.
And then in some future thing where we have it much more complicated, and we have some way to, we'll have some ABI to say, oh, hey, I see the interface report, I don't like it, and I want to change some stuff, and turn off ATS, whatever. Then that would be
you need to unbind and rebind
yeah,
without taking
unbind rebind. But that's a good catch. Okay. On the DMA buff thing, have you seen this thread from Jason?
Yeah, I see there's some discussions about in this thread, and the maintainers, the Christian, still have a big concern on exporting the file addresses out to importer. So I think we have much risks on there. I don't for now I don't want to move to the new this new mechanism because I think things are not stable.
It's not stable. Yeah, the last thing Jason did with this this plan, and so I think for the staging tree, I think we'll just continue to use your PFN exporter, even though Christian doesn't like it, and that'll just have to be what we use in the staging tree until this all gets clear.
Yeah.
Wait, I was under the impression that the VFIO can actually export DMA buff already. We don't have CDN support for it, but the VFIO can do it. So it's like we past that point, no? We're going to change it again.
You understand it right. Jason has upstreamed some patches to make a private channel between VFIO and IOMMUFD. We can just leverage that private channel also for KVM for now.
So what are you arguing now about?
So it means that we for now we could still use this VFIO private channel to get the physical address. Yeah, and wait to see how this new solution advance. We don't move to this new solution now.
Can we upstream? I guess can we upstream based on what's already there? Like, I guess why would we need to wait for this if we have the private channel?
I'm not sure. Maybe yes. We could upstream based on the private channel, but I'm not sure if Jason would be happy about that. I see he wants to push the standardization of this DMA buff things. But if you still want to create this private channel, it seems that we are not on his side.
I think, yeah, because if I look at this, like I think he wanted.
Dan is on his side.
But my impression from this was that he wanted this to be the mechanism, that this not use a private channel for this.
Yeah. He don't want to use a private channel.
Yeah.
But I think maybe if Christian always nag on exporting the physical addresses out, I don't have ideas how this thread would go, because on IOMMU side, it may be possible that there is some common helpers to map an ILVA, a user-defined ILVA to some physical address, but it is quite hard for KVM to do the same thing, because the guest address space mapping to the physical address, these mapping are not defined by some kernel component. It is defined by the by QEMU. So you cannot, basically, I don't think you cannot let KVM to export some kernel APIs to let other component to map a physical address to some uncertain address space. I think maybe that's a problem. I don't think KVM has some mechanism for this yet.
Okay. But nobody's worked on the private channel implementation on top. I guess it's pretty small, but it would be on top of what Leon did, the MMIO export for VFIO.
Yeah. There's a patch set that Jason posted to create the VFIO private channel for MMIO. The private channel, for now, the private channel is already upstreamed. It is between the VFIO and IOMMFD.
Okay. Okay. Yeah. So yeah. I get it, because those are kind of tightly coupled anyway. But expanding it outside of that relationship would be a problem. But we can probably take a look at that just for now, just to get it closer to what's upstream.
So I think for now maybe we could send. Is it possible we send some patches to just for the staging tree to build another private channel from VFIO to KVM? Then we could have some unified code on the staging tree.
I think so. I think yes, let's do that. And I can talk to Jason and be like, say, like, Jason, this is in support of getting to the final thing, and this is why it's in a staging tree.
So by this private channel, you mean the patches which Elon made to make it work with KVM, right?
Right.
While we're on this topic, was there any update these patches. I'm particularly care about MSIX exclusion from this DMA buff exporting. Or I have to write my own patch and send it. Yes? No?
Yes, no.
I have a device which uses, I have a device which has a MSIX bar in the middle of some other bar, and it breaks things. So I have to use a MSIX relocation hack in KMU, which I don't really like that much. So I want to get rid of it. So I either fix VFIO myself, or maybe Dylan has fixed it. So is there a fix, or patches are welcome?
Okay, maybe we could send out the initial patch, and then we then maybe
Okay,
you could
it's not fixed.
you could also reflect on that. Is that okay?
Okay, got it.
Or if you have the private channel patches on your side, and you already have some reflectons that maybe you also can send it out, and we can see.
I'm using yours from like 6 months ago, or even more now. So before I post anything, maybe there is something newer from you. Which you
okay. I can first update what I have now. This is the private channel things.
Okay, good. Push it out. Let us know. Thank you.
Okay.
And we are running out of time. But I have a small, well, probably not so small question. Do you have a concept of like on? Yes, speak.
Okay, no, go ahead. Sorry.
You know, the like modern CPUs are so big, they have a bunch of embedded devices which pretend to be PCI. And now, more often, they want to pretend to be disk devices, but they don't want or need IDE, but they still want this like state machine with config locked and run. And how are we gonna implement that? We make those devices pretend like real devices and do config lock and run and everything. Or we create a separate TSM driver for it, say not TSM0, but TSM1, and skip certain things. Because if it's on the die device, it doesn't need IDE, it doesn't need connect. It really doesn't. But it can simulate it by, faking IDE capabilities. And that's what we tend to do in AMD. But faking things to just make Linux kernel happy, and this stuff is just touched upstream. So
yeah,
that's the general approach.
But I mean, but it was just IDE. That's easy. Like I don't think it's like the current TSM core is okay with no IDE. Like if the device says it doesn't have IDE, but it does say I can do TIO, that's fine, because then you just connect it, and the connect won't do the connect doesn't have to. It probably doesn't even have to do SPDM as long as the. I mean, are you going to do certificates and evidence and interface reports, or no? Or these are just on-die things that are always trusted, and you just say go, or?
Well, that's another argument we're having internally, because if it's on a die device, then its evidence should come as a part of like this, like AVM, POCO VM attestation report. where like every on-die device is attested and certificates are provided to every guest, kind of thing. So it's not that the individual device will return certificates, but interface report should come from a device, right?
Right.
So there are some common things, but other things are not that common, and it's how we approach that.
I mean, in general, like I agree with you that we shouldn't, Linux shouldn't force people to add stupid things that have no meaning. And so yeah, if we can do things like some steps are optional, or validating the interface report and its authenticity is connected to some other root of trust that came.
Say one question I got was, what if we don't have SPDM or secure SPDM, but we want to do TDISP? How would we do that?
You don't want
just us,
you don't want to you don't have the SPDM and security SPDM, but you want to accept the device. Is it?
Correct. And the way to tell device it's accepted is TDISP. And PCI spec says it has to work on top of SPDM. But that SPDM, if you do it like SPDM way or TDISP way, PCI Express way, then that device will never tell you certificates and will have like very limited set of capabilities. Do you have any device like this in the works? Are you planning for this?
No, I'm not aware of somebody building this, but I don't. But also, it doesn't sound that bad just because the guest never sees SPDM anyway. The guest just executes some call that the host traps and says, "Oh, I got to do SPDM to do this," but like.
Yeah, guest support is easy on this, but the host support is not as much. We need to fake lots of things, or we don't. I take from this, it's not that much of hot topic now in anywhere outside of AMD.
I mean, I think I had somebody from Qualcomm ask me about this. They're like, "Oh, hey, we have a bunch of non-PCI devices that also want to do this."
All my devices pretend to be PCI.
Yeah. So I think as long as they pretend to be PCI, and then I think we can piecemeal turn off parts of the flow that don't need to be there, that don't make sense. That's my rough idea.
It seems that you have a package, you have a secure package, and if including the CPUs and the devices, and the thing is that you need to accept. You either need to accept all the secure package or reject it. Device would not provide. Devices could not provide evidence independently. But maybe
the device is not a device; it's just like another CPU which you attest.
Yeah. But I think maybe you should provide all your security evidence from the TD report, from the Coco VM report, to let the user knows that you have this secure package and you have the report for the whole secure package, and you don't have to check the device evidence one by one.
Yeah,
right. What I'm saying, we should be ready for devices who don't provide this individual per device evidence. So, and I'm kind of surprised to know that IDE is not required to make the whole thing work. I thought we still want IDE. I thought.
Even in the PCI spec or a SIG, or the spec says that IDE is optional. Like that, as long as the as long as the TSM firmware trusts the interconnect, then ID is optional.
Yeah, that's good. Like that. Cool. I ran out of questions.
Okay, and I ran out of time. So okay, yeah.
It's
so,
Friday. It's Friday here. Friday here already. So.
Okay, well
Yep.
go start the weekend. And I'll start getting this staging tree rebate, and we'll go from there. Okay, everyone. We will see you at the next one.
Yep.
Thanks.
Thank
Have
you.
a good night.
Cheers.
Thanks.
Bye.
Bye.
Thanks. Bye.